Yes, every section, two things at least, transformation, solving. We just did solving, we're gonna do graphing. All right, you can do this. People come back, people come, ooh, let's come back. All right, so we have two new parent functions that has to do with the radical form. First one is the square root x. So this is the first time we're looking at this, so let's go ahead and graph. We're going to put in some negative numbers, and we're going to put in some positive numbers, as well as 0. This time I'm actually going to go up to 4 because I know that the numbers turn out better that way. Okay, so when x is blah, 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 we're trying to check what y is. When x is negative 2, what is y? Yeah, so it's going to be square root negative 2, right? So we would say square root 2i. However, we're looking at a real graph. So what's the answer? No solution, nothing. It's not going to show up on the graph. The graph is only for real numbers, so nothing. Square root negative 1? Same thing, right. Nothing. We don't see anything. Square root 0? 0. Yeah, square root 0 is 0. Yeah, right. Okay, square root 1?
Oh, that's when you raise the power of 0.
Yeah, 1. Square root 2 is square root 2 unless you use your calculator, which we're going to do later on to figure out what that number is. Square root 3 is square root 3 again. Square root 4, 2. Only positive 2, okay? Not plus minus. We're looking at the square root graph, which means it's inherently positive. Okay, so now let's take out our graphing calculator and figure out what square root 2 and square root 3 are. Huh? You don't have a calculator? Oh, I'm sorry. Take out a calculator. A calculator. So square root 2, find the square root button in your calculator. What is square root 2?
1.41.
Okay, let's just stop at 1.4. I can't graph that accurately anyways, any more than tenths of a digit. What's square root 3?
1.7.
1.7. Okay, so let's go ahead and graph. So there are no negative x's. It starts at 0. And it goes 1, 1, 2, 1.4, 3, 1.7, and then 4, 2. It is not a straight line. It is a curvy line, and it gets kind of slanted as it goes. So this is the square root graph. You have to recognize how a square root graph will look like. Now let's look at a cube root graph. A cube root graph. So we're going to do the same thing. Let's start at, let's say, negative 3. Negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay, this is a cube root graph. Cube root, not square root. So what is the cube root of negative 3? Cube root negative 3, right, whatever that number is. It is actually a possible number, so you have to use your calculator to figure that out. So let's try to figure out where your cube root button is on your calculator. So if your partner can't find the cube root button, can you help him or her? And if both of you can't find it, let me know. So let's go ahead and put in all your values. So that's negative 1.4. Cube root of negative 2 is about negative 1.26. This is negative 1, 0, 1, 1.26, and 1.4. Make sure you can find the cube root button on your calculator in case you need it for something. Okay, so at a negative 3, this is a negative 1.4, so about here. Negative 2 is negative 1.26. Negative 1, I'm sorry, I think I graphed it too low. So negative 1.4 is here. Negative 1.26 is here. Negative 1, 0, 0. 0, 0, 1, 1, 2, 1.26, 3, 1.4. Okay, so this graph is going to look like this. This side looks just like the square root graph, kind of, a little bit lower, and it has a kind of wing this way. What you want to do is make sure this happens every year. Someone will kind of think about the cube root graph like that, but not quite. So then they kind of go like this. They're like, it's kind of like this. No, it's not. That is a very strange graph. I don't even know how you are going to get that graph. No, you cannot just graph anything you want. And you can't actually do this either. So some people, they will graph this and then their graph tilts up. It's not tilting up. It's getting flatter and flatter as it goes. Same thing here. It is not going down. Okay, it's not going down. It's going flat. Okay, so please don't draw it that way. They're both going kind of flat like this, not up and down. Okay? All right. Of course, every time we look at graphs, we must look at transformations. Okay, we should probably have everything memorized, right? Okay, vertical translation, A, H, or K? K. All right, K greater than 0, which direction? Up. So K less than 0, we're going to go down. All right, horizontal translation, A or H? H. You see X minus H, which direction do you go?
Right.
Correct. Okay, so X plus H, we're going to go left. Stretch and compress has to do with A, but the absolute value of A. So if absolute value of A is bigger than 1,
Stretch.
yes, stretch. If it's between 0 and 1, it's going to compress. Last one, reflection, x-axis and y-axis. X-axis is the negative inside or outside of the function? Outside. So negative is outside of the function. Y-axis, negative is inside. Okay. Let's go ahead and figure out transformation and graph. So we're going to start with easy ones. Did you guys copy everything down? You probably don't even need to copy it down. You can probably write the notes yourself because you got it all memorized. All right, first one. Before you do any kind of transformation analysis, you want to always try to ask yourself, what is the parent function? What is the parent function? Square root of x. Okay, can you show me with your arm how square root x looks like? Okay, only one hand. Okay, only one hand. Square root x only has one hand. All right, so then what is the transformation?
Right. Positive. Down 2.
Down 2. So this is the function. This is outside the function, so that's down 2. So we need to remember how the square root x function looks like. It's like the one-winged bird on the right-hand side. And it starts at 0 and then kind of tilts over. So it's going to go down 2. So it's going to start at negative 2 instead. Okay, so I know the numbers go 0, 0, 1, 1, 4, 2, because I'm just memorizing all the integer numbers. It goes down 2, so everything moves down 2.
So 3 points?
Yeah, 3 points is pretty good. Just like the general shape. Okay, so transformation, that is down 2. All right, next one. What is the parent function? Cube root x. Show me with your arms how cube root x looks like. Yes, 2 arms on this one. Cube root x is 2 arms. Okay, what is the transformation on this one?
Right 4.
Correct, right 4. So you gotta remember how your cube root x starts. That starts at 0, 0, and then one side goes up, one side goes down. What's gonna happen is at that 0, 0, it goes right 4. So it's gonna start here instead, and then something like that. Doesn't have to be perfect. You just have to make sure that your graph, again, does not go up and down. Okay, it goes kind of slanted, getting flatter and flatter as it goes.
Do you want to use points?
You can, but this is kind of a sketch, so you don't have to. All right, so let's have you guys try 1 and 2. Okay, so number 1 is up 1. Okay, so up 1 from square root x. So that's going to start here and looks like this. Okay, number 2, this is left 1. So we're going to start here. And then it goes down because this is cube root x. Any questions? Yeah.
So for the second one we did,
Mm-hmm.
we started on the x-axis.
Yeah.
So why don't we start on the y-axis?
Y-axis. No. So basically what you want to do is look at the hk of the original function. In the original function, the hk is 0, 0. So that's what you're moving. You're moving that 0, 0 to the left 1. So then left 1 means only move on the x-axis.
So then it would be 1, 0.
Negative 1, 0.
Negative 1, 0.
Yeah. All right, now we're ready to do more than one transformation. Okay, this gets pretty crazy. Again, you want to identify the parent function. So for this one, what is the parent function?
Square root x.
Square root x, very good. Okay, we have 4 transformations.
Up 1,
Okay, up 1,
right 3, compress by half.
right 3, hold on, I did it too fast. Okay. Across, what is across? Reflect. Okay, reflect. Reflect x-axis. And then what? Compress 1/2. Okay, up 1, right 3 is going to be where we start this graph. Up 1, right 3. So here. So we know that this is going to be a square root graph, so it's going to point to the right like that. However, it's going to be reflected across the x-axis, so it's going to go down. And then it's going to compress 1/2. Compress 1/2 means whatever was the height it was is now shrunk by 1/2. So we know that the points started with 0, 0, 1, 1, 4, 2. So then at 1, 1, it's now 1, 1/2. At 4, 2, it's now 4, 1. Does that make sense?
Yeah.
You're just shrinking that y by 1/2. But we're going to reflect it over, so it actually ends up being like something like this.
Okay.
So again, you start with your h and k. That point is not going to move. Then you do your reflection or compression as it requires. Good? Okay, next one. What is the transformation on this one? Or what's the parent function? Sorry. Cube root x. And then what's the transformation? There are 3. Stretch 2. Huh? Down 4. Left 1. Okay, so my hk has moved. It's now down 4, left 1. Down 4, left 1. So it starts here. It's going to stretch 2, so whatever height it was is now multiplied by 2. So it was at 0, 0, 1, 1. Now it's going to be 0, 0, 1, 2. So then it's going to be here. And then same thing here. Something like that. Doesn't have to be perfect. If you want it to be perfect, you have to put your table out and calculate each point. All right, we're going to do the hardest one now. This is tricky because if you look at this one here, there is a number next to x. When that happens, you have to do some other stuff. Okay, first of all, what is the parent function?
Square root x.
Square root x. Okay, when there are numbers next to x, what you need to do is you need to factor. You need to factor whatever is next to x. So we need to take the 9 out. So if I take 9 out, what is left over of that binomial? X plus 2. And then what I'm going to do is I'm going to split this radical. So remember that inside a radical, if things are multiplied together, you can split it. So this is going to be square root 9 times square root x plus 2. So it's easier to see. Next year, you're not really going to split because you're going to learn something different. Yeah, that would, we'll wait till next year. Okay, so square root 9 is 3. So this is 3 square root x plus 2. So now it's easy to graph. If you, if you have a number next to x, you have to factor out that entire thing. Even if it's not factorable with the 18, you have to take it out entirely. Okay, anyways, I'll give you more examples. So go ahead and graph this one, write the transformation as well. Okay, what are the transformations? Good, stretch 3, left 2. So we're going to go left 2 and then stretch 3, so something like that. Good? All right, you guys give the last one a try.
Are you putting a note?
Huh? Oh, sorry. The note. In order to determine the vertical stretch or compress, the coefficient next to x must be 1. If it's not 1, you have to factor it out. Okay, so try this last one. Let me know when you are done with your transformation and graph. Okay, so this one, what you want to do is change it. So take out the 8, so it's x plus 4 minus 2, so it ends up being 2 cube root x plus 4 minus 2. All right, that means left 4 down 2, stretch 2, so, I'm sorry, something like that. Left 4, stretch 2, down 2. Okay, let's try one more. This is going to be the hardest one that you'll have. Yes, so I'm going to give it to you. Y equals negative 27x minus 9 to the 1/3 plus 2. Gotta think about it. Gotta think about it. Negative 27x minus 9 to the 1/3 plus 2. This one has 4 transformations. Remember, you gotta make the coefficient next to x 1. That means you gotta take out the entire negative 27. You gotta take out the entire negative 27. It's gonna leave h a fraction. It's not a perfect factor. So you gotta think how that looks like. Okay, to the 1/3 just means cube root, right? So this is the cube root graph. What we want to do is make sure we take out that entire negative 27. So taking out the entire negative 27 means that you're factoring that out. Factoring it out means we're dividing everything by negative 27. It's just another way to think about it if you weren't sure how to really factor that out. So you're dividing every term by negative 27. That means the first term is just going to be x. What about that second term? 1/3 plus 1/3, yes. And then everything is still to the 1/3 plus 2. We are not cubing everything. We're not raising everything by 3. We can't change that. So we're just kind of minorly changing some things. Okay, so this 1/3 is going to apply to both factors. So this is going to be negative 27 to the 1/3, and then x plus 1/3 to the 1/3, and that's still a plus 2. Okay, so simplify from here. You need the transformations and graph it. Let me know when you are done. All right, so final version. Negative 3 cube root x plus 1/3 plus 2. So this is going to be left 1/3, up 2, stretch 3, reflect x-axis. All right, graphing it. Oh, let's do it here. Left 1/3, up 2, stretch 3, but this is reflected, so it's going to go this way. Okay, so please be careful. When you reflect, you do reflect the whole thing the other way. That's it. Submit your notes and we are done.